Hi folks. Hey, welcome back. I've been doing some thinking. We've got our introductory series, we've got the project series are out there. And as we look at Defold, some of these can get a little bit long, a little tedious. So we're going to focus on this series, short and sweet. We're going to look at what I call vignettes, short little primers on selected topics. The first topic we're going to look at is something called parallax. Parallax gives you that perception of depth and movement. It's an illusion, if you will. You see it in a lot of different genres, and I think you're going to find that it might be very helpful for the type of game you might be looking to build. Each of these vignettes is really going to focus on three things. What's that end result look like? That way you can make a determination early on whether it fits into what you're looking to build. What's the default project structure associated with putting that in place? And what are the unique techniques that we want to apply, and do a deep dive into each of those techniques so you can really fully understand them. Obviously, each of them are going to have a project in a zip file on a shared Google Drive, so you can download it, take a look at it. So I think you're going to find this one pretty interesting. Let me stop talking and let's go ahead and jump into it. So as you can see, we've got an animated character. He appears to be walking to the right. He's not actually moving, but it appears, the perception is that he is, because the foreground is moving at one speed. A set of clouds is moving a little bit more slowly, which gives it the perception of being a little bit more distant. And then the sky with the moon is essentially standing still, because for all intents and purposes, it's an infinite distance behind. And so that's it. So let's jump into seeing how that's done. This is a pretty simple vignette, so I'm really not going to dwell on the project structure too much, except to really focus on the key design feature that I felt was kind of an important way to deal with this. And that's that I'm going to have not just a single main dot collection, but the main dot collection is going to have two subordinate collections. It's going to have a foreground collection, the foreground being the tree line. And in that, we'll have multiple game objects that represent each of those panels, as well as a Lua script. And so that'll be a foreground collection. Then I'm going to have a cloud collection that collects up all of the game objects with the associated sprites and the controlling Lua script associated with those clouds. That'll be a second collection. So a main dot collection will have the foreground collection. It'll have a cloud collection. Then it's going to have three separate game objects. It's going to have a game object for the sky with a sprite. It's going to have a game object for the walking character. And then how can you have any game without, a little self-pizzazz? So you put the logo in there. So it'll be a game object associated with the logo. So let's go ahead now and dive into the asset panel using the default game engine and take a more close look at each of those various components. Without taking too much time, let's conduct a walkthrough of the entire default project structure from the top, as we show here in the asset panel. Let's start with the graphic assets. For this project, I've included a series of image files. There's a character walking sequence with essentially elements of a sprite sheet that you can see here in the 7 distinct walk PNGs. And there's also a set of separate images for clouds, ground, a logo, and the sky. Importantly, I want to provide appropriate credit here to craftpix.net. It's a really great resource for image assets. I really highly recommend them. In addition to an extensive series of very reasonably priced paid images, CraftPix also offers a set of what they call freebie products. And as you read their licensing, you're permitted to use those resources, the freebie resources, in both personal and commercial projects. You can modify them and include them in your game projects and other projects you work on. Okay, let's get back to our walkthrough of the project structure. Let's go through game.project. There's really only two project settings that are changed from the default. First is I've renamed the title to be Vignette 1 Parallax. Secondly, I've resized the display to a width of 1024 and a height of 768. As I move to game input bindings, there's no surprises here. Button 1 input reflects a, quote, touch action, but please note there is not going to be any user interaction with the application in this project. That's simply the default setting. Our script repository. We're going to review the Lua script in detail in the next section when we talk about unique techniques. But now, just know that both the script files are located within the script repository folder. There's a G controller that drives the logic for the foreground, the tree layer, and there's a C controller for the cloud layer. The main folder contains the foreground and the cloud collections, as well as an atlas containing our graphic assets. Just for completeness, I'm going to walk through each of these components, starting with the easiest, the atlas. The graphic assets.atlas consists of 5 standalone images: clouds 1, sky, our parallax logo, and ground 1024. In an animation group, care walking. That's the animation group supporting the walking character. Importantly, the animation character walking is set for 7 frames per second on a loop forward playback basis. Lastly, you'll notice that extrude borders is set to 2. That prevents edge bleeding as you combine all of these different images into an atlas. That's a topic we discussed in the introductory tutorials. Foreground collection. The foreground collection consists of 4 game objects: foreground 1, foreground 2, foreground 3, and a ground controller. The ground controller is basically the container for the G controller script. You know, the positioning of both the game objects and their component sprites has been designed to simplify the overall logic. Let's take a look at how this project does that. First, let's look at how we designate the position for foreground 1, both the game object as well as the component sprite. We place the game object to be centered at the origin of the screen's display, an X position of 0 and a Y position of 0. So we set the image X position to 512, aka half the width of the screen. You see here that we've set the Y position to 288. That's not half of the height. That's lower than that because we want to place the tree line on the lower half of the screen. So what about foreground 2 and foreground 3, the other 2 game objects? Let's go through this step by step. First, if the position of the foreground 1 game object is located at the origin, then in order for foreground 2 to abut against its right edge, we want to place the X position of foreground 2 to be 1024. And we want the X position of foreground 3 to be 2048. As we did for foreground 1, we're going to place the sprite component at X512 and Y288 so they have that same relative positioning. Now that we've planned out how we want to position each of these foreground game objects and those component sprites, let's just quickly walk through how that's reflected within our default project structure. Foreground 1, positioning of the game object, positioning of the sprite. Similarly, foreground 2, positioning of the game object, positioning of the sprite. And lastly, foreground 3, positioning of the game object, positioning of the sprite. The fourth element in the main folder is the cloud collection. It's very similar structured to what we did with the foreground. It consists of the 3 game objects, cloud A, B, and C, each of which consists of a sprite. That sprite references the graphic assets atlas. The default animation is clouds 1. It's got a cloud control container that contains the C controller Lua script file. The positioning for clouds A, B, and C, both the game object and the sprite, is fully consistent to the way we accomplished the same thing for the foreground. Let's move on to our main collection. Main collection consists of the following. It's really a collection of collections. So main is what's initiated based on its citing in the game.project. That's what starts the program. It immediately invokes the cloud collection and the foreground collection. There's 3 additional game objects associated with the main collection. There's our logo. Okay, you always have to have a logo. I've located it, as you see here, at 150/700. I've downscaled it a little bit because the logo image is fairly large. I've given a Z index of 0.8 to put it at the very top layer. And I've assigned a sprite to it. References our graphic assets. Atlas, obviously, using the Parallax logo as the default animation. We have our sky background. This is the furthest away at the greatest distance. It's not going to be moving. It's simply going to be a game object with a subordinate sprite. I locate it at the center of the screen, 512, 384. I give it a minus 0.5 z-index to place it behind all of the other game objects. Lastly, I have our walking character. Just to add a little pizzazz, we've added this game object with a sprite. In this particular case, as you can see, the sprite references our graphic assets Atlas, but the character walking animation group. Just for completeness, it's located at 650, 175 with a z-index of 0.8. In this third section of the Parallax vignette, we're going to look more closely at several specific defold techniques that are integral to implementing the parallax effects within your game. Probably first and foremost is the manipulation of the multiple panels that constitute each layer. Well, before we get too far ahead of ourselves, let's work through how we can apply a set of scrolling panel game objects on top of a stationary sky game object. Let's start with the foreground, aka the tree line. We want that tree line in front of the sky, and we want it to move to the left. It should look like this. Please note, I've artificially added a yellow line at the edge of each of the panel images, just so you can see how they abut against each other. Obviously, we're going to remove that line for the final product. So how are we doing it? So here we have 3 foreground game objects. That constitutes that foreground panel, which we position within a cascade, left to right, edge to edge. The multiple images are going to move to the left at a constant speed, all at the same speed. And we're going to set that speed to be higher than we want the clouds to move. That'll make the tree line appear closer to the user than the clouds. To enable continuous flow in your game, when a game object with its image moves off the screen to the left, we will want our controlling script file to move that game object all the way over to the right of the last image in line. We're going to use Lewis script to pull all the pieces of our deep dive techniques together. So this final piece is going to be a walkthrough of 2 of the controller scripts. The first controller script is G controller for ground, the foreground controller. And the second script is going to be C controller for clouds. And let's go through the ground first, and you'll see that the clouds is very, very similar. Obviously, we always start any script file with a comment header, as you can see here. Next, we're going to set up a local table, and that's going to contain the IDs of each of the 3 foreground game objects. That's going to make our ability to iterate any logic we need to apply across all 3 game objects much easier. During initialization, that is the init function, we need to obtain the size of the foreground sprite image. We're going to use the geo.get API, and then we're going to apply that into a geo property, a script property called gImageSize. Let's go ahead and take a look at that API in some detail. The geo.getGameObject API. I've found this to be a pretty handy feature. Using that API, it allows you to include some flexibility within your script. For example, let's say you want to change the sprite's image to something with different dimensions. By dynamically determining the image's dimensions, you wouldn't have to then modify your code to accommodate that new image. So how does the GeoGetDefold API work? In our example, we query the sprite component of the game object foreground1 at address, quote, foreground1 # sprite, sending it the property size. From that, the API returns the image's size, but please note it's sent in vector3 format. Okay, now back to the gController script. We also set another script property, gspeed, and in this case we're going to set it to 75. Within the update function, several actions are going to occur each frame, and they're going to be applied across all the elements of the gsegments table. And we do that by using the for I, p in I pairs Lua iteration loop. That's where I is the index and p is the table value for that index. Inside that loop, we see a local variable, POS, pause, is set to the current game object position. That position is checked to see if it has now moved far enough to the left that it's left of a full image width from the left edge of the viewport. If it is, then the game object is moved all the way to the right-hand side of the full cascade, as we saw in the illustration here just a short time ago. Then, the game object continues to move incrementally to the left by the distance self.gspeed times dt, the delta in time since the last frame, and that will reset its position. All right, real quick, we're going to take a look at the cloud controller, C controller. As you can see, as we're going to walk through it, it's essentially the same. Obviously, we changed the IDs inside the local table C segments. They are going to move at a slower speed because they're farther away, and that's really the parallax technique that we're really trying to illustrate here. And the update cycle is essentially the same. Yes, I know. It could have been cleaner if I combined both the foreground and the cloud controls into a single controller script, but I've really chosen keeping them apart just to segment them, basically for instructional purposes, to keep it clean. Okay, hey, that about wraps it up. Hey, here's our final result again. It reflects all the techniques that we've just talked about. And I'm hoping maybe you have a game that you're thinking about developing where maybe you can use this. And if so, and this is helpful, hey, that's what these tutorials are really all about. I would definitely appreciate any recommendations in terms of depth, length, the approach that we're taking on these, and in particular, if there's any specific topics that you'd like addressed. That'd be really helpful, and I'll try to put that into the build queue. If you haven't yet, if you subscribe, that really helps in terms of getting notifications. I'm going to be releasing these vignettes one at a time. I'm not going to wait for the whole series or a whole clump of these to be done. They're too hard to predict, so they're out there. Hey, listen, I don't want to ask for a cup of coffee. I don't want to ask for a Patreon subscription. I was thinking about something a little bit different. So I've taken this vignette, I'm going to do these for all of them, and I've converted it into an ebook. That's about 35, 40 pages, maybe 45 when it's all spruced up. I've got an ebook store that I've placed it in. There's a link to that store here down below in the description paragraphs associated with the YouTube video. I've put a very nominal fee on it, 99 US cents. So it's about a third of a cup of coffee. So if those kinds of things are helpful for you, I know I like looking at a book sometimes, videos, I have to keep rewinding or whatever. Please feel free. I would greatly appreciate that support. And hey, listen, lastly, but maybe most importantly, this full project is out on a shared Google Drive. The link is down here below. That'll give you a chance to download the project and work through it, tweak it as you deem appropriate. So with that as a close, I appreciate everybody's support, and I'm looking forward to getting the next one of these out here shortly. Not measured in months, hopefully in days. Okay, hey, take care now. Bye-bye.